Hey everyone, and welcome back to the Hybrid Friends. As you can see already on the screen, today I'm back here with my friend Oriol, and as we had in our last discussion, um, you know, the discussion we had before, we were introducing some concepts about platform infrastructure independent applications, in our example based on Kubernetes. And we got a lot of questions on how to load balance and globally load balance those applications. So I invited Oriol again for explaining us how it works. But over to you, Oriol. I know there were some changes in your job role recently, so maybe you can reintroduce yourself to the audience, and then we proceed with our chat.
Absolutely. So fair enough. My name is Oriol Ardevol. Been here with you guys before. I am now a principal consultant within Microsoft, an SME on containerization technologies and focusing especially on hybrid technologies around AKS hybrid and running containerized workloads on premises, which may or may not be connected to the Azure cloud. So that's my area of expertise, and I'm happy to be here with you today to continue our conversation around how to build those geo-balanced multi-cluster solutions around AKS.
Thank you. So going back to our scenario, Oriol, it's so we now have all our applications running, partly on AWS, partly on Azure, maybe on Azure Stack HCI or VMware, and all of them are now having the same applications. But what should we do at first to have one single entry point for those applications on all platforms? What is it? I cannot set up a load balancer, for example, which is then in one location and then connecting all of them. But is there a solution to maybe combine them globally or combine them to the different infrastructures?
Yes. So once we have our application in our cluster, so the next step for us would be to build a multi-cluster solutions. There could be a variety of reasons behind that. It might be DR or failover scenario motivations where you want to have duplicated or redundant infrastructure running the same applications across different regions. Maybe it's about proximity of your clients to your infrastructure, so to make sure that they get low latency response from the service. So there is a variety of scenarios and different configurations that we can set up, but we could summarize many of them as having multiple clusters running the same applications, multiple AKS clusters. They could be located, maybe some of them on premises, some of them in cloud providers, but they are hosting the same applications. And like you said, the first thing that we need to consider is once we have those applications, ideally each cluster is going to present some public endpoints to, or potentially public endpoints to the internet to be able to access those applications. Okay, so depending on the motivations behind this multi-cluster topology, we need to think about how we are going to distribute the requests across those clusters. Obviously, having our own physical or load balancer instance in one of the regions that we're trying to load balance is not a good solution, because that becomes a single point of failure. If that cluster or that solution was down, then effectively all of our clusters across the globe will be impacted. So we need global load balancer solutions to do so. Okay. For instance, in Azure, we have a different set of services that can help us with this. So the most typical one and most broadly used could potentially be Azure Traffic Manager, which is a global service that implements DNS-based load balancing solutions where we have different endpoints and we can configure multiple algorithms to distribute the request to our backend clusters. So like proximity, like weighted distribution, different approaches. The important thing there is that it's DNS-based. We could also have other DNS-based solutions out there. Other alternatives that we might have is things like Azure Frontier, for instance, which leverages our pub location of servers across the globe to connect our users to, and then we can configure multiple backends. So as long as there is a public IP presented by our clusters, or if they are hosted in Azure, it does not necessarily need to be public. We can implement a variety of extremely advanced load balancing algorithms to distribute requests across those clusters. Some other Azure-based technologies that we could look into is if we have a private connectivity, like those clusters are AKS clusters or on-prem clusters connected to ExpressRoute with our clusters, we could consider to something like our cross-region load balancer, which is in preview right now, which could maybe potentially help in those situations. If we don't want to use Azure, it's totally fine. There are other CDN providers that can provide this kind of global load balancing solutions, such as Cloudflare, Akamai, you name it. All of those kind of provide these alternatives and very advanced load balancing algorithms that we can use based on our multi-cluster scenario.
Okay. And if those, or is there an option? For example, normally when we're users, we are now in these work from home scenarios, but sometimes we have users walking into our offices, and there is maybe a local instance of the application running on HCI, VMware, as we said. Is it possible, for example, to create a DNS entry in my DNS server locally, then pointing to these specific local instance of of my applications, or is that then limited for only pointing globally with Traffic Manager, Akamai, etc.?
No, you could certainly use your local DNS server to point to your specific local HCI and AKS hybrid infrastructure. The thing that you need to take into consideration is if this is for failover reasoning, your failover scenario. So in the event of that cluster being down, how you're going to detect it, how you're going to change your DNS entry. If your DNS infrastructure already has support for it, then you might be good through health probes or something to identify the health state of the various clusters. But this is something that then you need to incorporate in your DNS design, if that's your scenario.
Okay. And now having all these clusters globally accessible, globally load balanced, they all may be storing data. So let's say it's an accounting software where someone is hacking in a new customer with his last order and maybe customer value, etc., etc. So that's now in my cluster in Asia. So how do I get those information globally distributed so that the account team from the US, from Europe, from Africa knows about the new customer and maybe can add child customers or child companies to that specific account?
Yes. So once we have those multi-cluster solutions, so like we said, load balancing is your first question that you need to solve, and then we need to understand the nature of the applications that we're hosting. So the easiest scenario is about a stateless application, so no data or state involved at all. That's pretty straightforward. We don't have to do anything. Second scenario is applications that deal with state. Okay, and under this scenario, we can have a variety of multiple services that those applications might be using. Let's say, for instance, that our accounting solution uses database for storing lay records, and that we need to have that data replicated across all of our locations for failover DR purposes. Then it's an application question at the database level. So what are the replication features that this database instance supports? Like if we're dealing with SQL managed instance, then we can implement things like SQL availability. Groups are always on groups to replicate the data seamlessly across locations. If we're using Cassandra or MongoDBs, then or Kafka, then we can implement Kafka replication topics across different instances worldwide to make sure that the data is replicated synchronously or asynchronously. Those are things that we need to take into consideration, especially for failover scenario, RTO, RPO. All of those will be provided by the actual underlying data technology that we're using. If we are using Kubernetes persistent volumes, disk attached volumes for our applications, and that state also needs to be shared across all our clusters. We will need to look into a solution at the disk replication level that can help us to do so. If we want to stick, for instance, to Kubernetes technologies, we can look at products like Longhorn, or which is a CNCF incubation project for state management, or also Rook, which is a Kubernetes implementation of Ceph, which also distributed disk management interface that allows us to replicate the data from persistent volumes attached to our pods in Kubernetes to multiple regions. So make sure that in the event of a failover, or if the user was somehow redirected to the secondary instance on a different location for whichever load balancing reasons, we could think of that the state of the data is replicated across all our instance, ideally in an active or active passive scenario if this was a failover. Okay.
And from your experience, what kind of replication would you prefer? Is it more the database level replication or the storage base replication?
That's I would have my preferences, but that normally is up to the applications that we're planning to host. Okay, so we can prefer, and I would probably prefer some database replications technologies which are very advanced and allow us to do things like synchronous replication patterns at the custom certain latency maybe, but that will give us the assurance that no data will be committed until it's replicated across different clusters in potentially different geolocations. So it gives us more flexibility, but the impact is that it's a specific or tailored to that specific solution. Okay. In other scenarios, we will have no choice but to implement Kubernetes persistent volumes or disk-based storage attached to our pods. Then we will need to look into those third-party providers for this kind of solutions. Okay.
From a backup perspective, would you rather think backing up only one instance of my globally distributed, synchronized and replicated applications, or would you say, okay, I need to back up every single application in every single region? Or do I just set up another dummy copy somewhere in my data center where I have my local backup server, etc., and then using that one as not accessible, more passive instance, and then using it just for backup?
I would say that ultimately comes down to your application or service level agreement requirements. You need to think about the different backup strategies that you're doing, and more importantly, the RPO parameters. So if you have a scenario where you have an active passive cluster, so the active will be replicating to the passive or failover scenario, and you are using a technology for replication that has asynchronous replication, meaning that there's going to be potentially some data loss involved, then that's what you need to take into consideration. And you will probably be taking backups from the primary side to avoid any data loss. And you can use for that purposes, if we're talking about database kind of state management applications, you can use database-specific tools. If there are persistent volumes, you can use Kubernetes snapshots and volume snapshot tools, or even tools that will manage those snapshots for you, such as Velero or Custom, which we already discussed in our previous call. And I would probably normally be taking those from the primary side. If I have a global distributed applications across multiple active clusters with bidirectional replication being configured in between them, it might make sense then to take backup from all of the different clusters to minimize the data loss in the event of a failure of one of them, because since all replication might be asynchronous, then there is a potential data loss if one of the secondary cluster fails and we're not taking backup from there. So I would say it's up to an application service level agreement discussion, which is the best approach for this.
Okay. So management you already discussed. So if you have a fleet of those clusters, maybe it makes sense to use, for example, products like Azure Arc for Kubernetes, or third-party partner products. So we had that in our previous call, so everyone who's interested, we discussed that in our previous discussion. Is there anything or any learnings, do's and don'ts you had throughout your time working with those stuff?
Sure. For a multi-cluster scenario across different regions, a couple of things that are worth discussing. First of all is ideally, as you have more and more clusters, you need a multi-cluster management tool. We already discussed Arc, you can use it or not, or another multi-cluster management tool such as Rancher. I think it is important to embrace things like GitOps for application deployment and distribution across clusters. A GitOps model will help you seamlessly distribute updates to all of your clusters extremely easily, and you will not have to as the number of your clusters increase across regions, it will make it much more easier for you to manage the deployments in those clusters and the configuration of those clusters, rather than to having to connect to each one of them separately and applying the necessary configuration. So GitOps for multi-cluster environment, whether you have a multi-cluster management tool or not, it's, I would say, kind of very, very interesting. Another thing I wanted to mention for multi-cluster scenarios is we also have the ability nowadays to leverage service mesh capabilities to help us in this multi-cluster scenario. So for instance, if we are deploying a service mesh with like Istio, which is extremely popular, and the one that we are also now deploying in Azure Kubernetes clusters as well, if you choose to, then you can implement a multi-cluster scenario completely transparent to the application themselves. And with potentially, depending on the scenario, not even global load balancing solution needed, so that once a request goes into a cluster, the service endpoints are seamlessly distributed across different clusters in various approaches, maybe an active passive scenario for failover, maybe active for all of the requests. And we can deploy this in Istio in a multi-network configuration where we have our clustered on isolated networks, and Istio is going to use something like an endpoint gateway to distribute requests across all of our clusters seamlessly, which make it, once the base infrastructure has been deployed, it makes it very easy for our developers to leverage that multi-cluster infrastructure regardless of how their applications are deployed. So it's seamless to them. They are calling a service, which might be calling a local service in our cluster, or might be traveling to a cluster at a different location because of whichever parameter or load balancing configuration we have decided. So these kind of scenarios around service mesh plus endpoint gateways distributed at the edge of our cluster. Obviously, we need connectivity in between those clusters over public or private network, whatever you have. Opens a lot of very interesting possibilities for multi-clusters environment, okay? Because on the different approach that we've discussed now, before that, once we had our clusters with all of our applications deployed, once a request went to one of our clusters, it stayed there, right? There was no cluster-to-cluster communication at the backend service level. Service meshes in a multi-cluster environment allow this capability, okay? Another final thing that's interesting mention is once, whether we have service mesh implementations or not deployed in the cluster, we can leverage products that we have at our disposal in Kubernetes, such as Flagger, for instance, which is a routing capability tool that allows us to implement extremely interesting routing strategies within our clusters, and even in a multi-cluster environment, to implement like things like canary deployment of our applications, Blueclid deployment, and pretty advanced routing technologies depending on the configuration that we have in our clusters deployed. Like if we have Istio, or we have another service mesh, or we have plain Kubernetes service and vanilla, we have different deployment and routing technologies at our disposal that we can use together with those multi-cluster scenarios that we have mentioned for implementing really cool and advanced scenarios around multi-clusters and different locations.
Okay. Amazing talk, Oriol. So I know we have a lot of frequently asked questions we could also add, but let's do that in a separate video, someone later at the stage. And we thank you for sharing your knowledge, and happy to, again, I told you that offline already, to have you staying on the team. So in our last video, we said, okay, you may be leaving, and now amazing to have you here, or to keep you here with us. So from my end, it's all I wanted to know for today. We already had the do's and don'ts. Is there any final words you want to share?
No, like I said, I'm really happy to be with you, hoping to contribute more to those. If people have very specific questions around, for a fact session, maybe around AKS hybrid or this kind of any Kubernetes related question in general, feel free to use comments, to send them straight to our team. And I am happy to have them on a single session to review all of those frequently asked questions that a lot of people have around these Kubernetes configurations.
Perfect, thank you. So you heard it. If you have more questions to Oriol, use the comments, subscribe our channel, and there will be more videos coming through our channels. And yeah, thank you again, my friend, for having that talk, and have an amazing day.
Thank you. Thank you all. Cheers.